All right, so we're COMP100, and it's officially week 6, lesson 6, part 1. And last week, just as a recap, we covered decisions. But one thing we didn't have a chance to cover was the switch statement, right? So let's take a look at that right now. So the keywords associated with the structure are switch, case, break, and default, right? You too. So what you've got is the ability for us to do, typically what we have is a situation where we have if else, if else, like this, right? This is kind of a really bad situation, right? So in other words, you kind of do this. You say if year 1 is equal to 1, or year is equal to 1, then write freshman. Else, if year is equal to 2, then you write line sophomore, and so on. These are just the way you look at high school years, right? Else, the final else, you write line invalid year, because if you're not 1, 2, 3, or 4, then what year are you? Right? You're there 4 years in high school, right? There's no 5th year, unless you're doing like what is it called, the victory lap, right? The victory lap, right? So so that's kind of the issue. So how do we do it? However, they have another kind of structure like this, which looks much cleaner. Take a look. So this structure, it uses the same thing. We're still checking year out. But instead of going if, years 1 or 2 or 3 or 4, we have this structure that we use case. So the word case, and inside the switch statement is, what we're looking at is these curly braces, right, is the code block. Okay, so this is the code block for the switch statement. Let's try an example. So I'm going to go into new projects, right, and we're going to call this a console application. If you can't follow along with the computer in front of you, like your laptop, then just use the computer in front of you. The school computer should be fine, but obviously you have more control with the laptop. So COMP100, and we'll say lesson 6, and we'll call it part 1 because I'm going to do a couple of parts here today. So I'm going to press OK. I'm also going to go into GitHub. So for you guys to follow me, I know some of you guys are saying that you follow me on GitHub there. That's fine. So I'm going to create a new repository on GitHub. I'm going to call it the same name, COMP100, lesson 6, and then part 1. Right? Okay. Great repository. I'm going to grab the repository from GitHub. And I'm going to go back to GitHub and right-click. I'm going to go add. Sorry, what am I doing here? Team Explorer, changes, and I'm going to say created base C# VS project. Right, there we are. Click commit. And then, of course, we're going to go home and then unsync commits, and we're going to kind of enter this repository. So now the repository should be synced up, so you're going to have what I have. Okay, so we're going to do it right in here, right inside of our main program right here, right? Ready?
Yeah.
Thanks. Tell her not to call for the rest of the time because it's annoying.
I'm trying to tell her.
Tell her you're in class, or take it outside, buddy. All right, so here's how it's going to be. So we have a year. Let's get a couple of things set up, okay, like we did last time. So one of the things we got to set up is some kind of input for us, right? So just to say like, please enter year. Remember like how we did like an input last time? So remember, what is the rule if we look at inputs from the console? When I read the console, what kind of data am I getting in from the console? What kind of data type am I getting? Every time I read something from the console, what am I getting? String, right? Every time I get something from the console, it's a string. So every time I get it in, I got to convert it. And I got to use my convert to function to whatever it's going to be. So the first thing is let's set up a placeholder for my stuff. Like for example, this example year. So I'm going to call it year, right? And we're going to set it up with, as this is my first variable, year, right? And the next piece I want to kind of set up is just a placeholder for what we get in called prompt. Now again, you don't have to do this. You can make it so that prompt, and this prompt is going to be a string type, right? Here's prompt. And what I want to do with prompt is I want to say prompt is equal to console.readline. There it is. So prompt is equal to console.readline. So this is going to take in whatever we type into the console, just to recap, and it's going to put it inside our prompt variable. So the value that's coming from our console, whatever we type in, is going to go into the prompt variable. It's going to hold it there. We also have to probably give a message to the user, because we have to give some nice messages, or else the user is not going to know what to do. So writeLine, console.writeLine, and we're going to say, please enter your name, right? Give a space. Actually, instead of console.writeLine, we'll do a console.write, because that'll keep us on the same line, right? So the same line as the read. Okay, cool. So we've got that. I'm going to just give a space, console.write, with a \n. What's the \n? Do you guys remember what that does? It's a skip on line, right? It's a new line character. That's what it does. It's the same as saying this connotation here. If I write this, it's the same as doing this. Like that. Same thing.
What's the point? Why don't you just do writeLine?
Because this, sometimes you'll need to do this with some kind of escape character. I want to show you both ways.
Oh,
You have to know both ways. WriteLine is typically the way we do it, but this \n, which sends a new line character to the console, is exactly what WriteLine does in the background. Let me just enter a semicolon there, because I forgot that. And I'll use the \n for now, just as that, so we see that form. Okay, that's cool. And we typically want to kind of stop the console from opening and shutting, right? Because it kind of pops open and shuts. So again, what I want to do is kind of do a console. We'll do this one time, console.writeLine. And in here, we'll kind of do a separator. So some kind of separator. I just use pluses or equals or whatever, some kind of fancy separator. And underneath that, I'm going to go console.writeLine. And I'll say press any key to exit, right? And then I'll do a console.read key, right? Console.read key will basically read from the console to tell me that, you know, I'm waiting for a key. Okay, that's what it'll do. That's all it does. Okay, we'll do that over and over again. I'm just going to kind of space down a little bit, because we're going to add some more things in there. And remember, one of the things, does the compiler care how many spaces I have in my code? Does the compiler care or read any kind of comments? Like, for example, this comment here I'm going to put in, which is, hey, wait for a key to be pressed before continuing. This is a comment in green. I use double forward slash, and what it does is it's basically ignored by the compiler. Just stuff to remember. So when I ask you to put in comments, if you do an assignment, like for today, I'm going to ask you to do a little assignment today in class, then I'm going to ask you to put some comments in there, right? And then there's going to be, right now we got year and everything else. We're getting prompt. Okay, I'm using a console.write, but I want to take the information we get into prompt and I got to convert it, right? Because like you said, it comes in as a string, and we can't use the year right now unless you know, we convert it to something else. So we're going to do that now. So we're going to say year is equal to convert dot. And we know it's year is an integer, so we want to go int. Now there's three options: int 16, int 32, int 64. And if you hover over the int here, take a look. From hovering over the int, it says it's a type struct. That's what it is. And it's of type system.int32. So int32 seems to be the right choice for us to convert. Okay? If you try anything else, it'll give you an error. And then I'm going to cut in brackets. I'm going to send the value that I'm going to convert, right? So what am I converting, right? So if I have to convert prompt, right? I'm going to convert this value. I'm going to take this value and convert it to an integer and set it inside of year. That's what I'm doing here. Okay, cool. So I got my year. Please enter your name. Sorry, it's not a name I got to enter. It's please enter your age. How about that? Please enter your age. And then maybe instead of putting year, right, we'll call it, let's refactor. Do you remember how to refactor? Right click on the actual thing you're refactoring. We're going to go to Refactor Rename, or you can press F2 if you're using a PC. And then inside there, we're going to just call this age, because we're going to ask for the age, right? Here we go. So here's my age. I'm asking for the age. I'm reading from the console. I'm putting another write I'm getting age. The variable age now has the value that I entered for my console, and we're assuming again that the console, whatever you enter in the console, is perfect. Like you can't put in something wrong that's going to mess you up or break your program. For now. Okay, that's the first thing. Now what I want to do is I want to check if the person's older, like we did last time. Remember we checked if the person's young, under 10 years old, and we kind of give a message and so on. Well, we can do the same thing, but we can do something like this. We can check for exact ages. I can't check for a range necessarily with the case and switch statements. But I can switch. So the way I start my switch statement is like this. Switch. And in brackets, the what I'm putting in here. If I go into, let me just get rid of that for a second. If I open a bracket and I want to try and see what that is, right? Typically what it is, if I want to get code hinting, is I want to enter something in there that makes sense. So we're going to switch age, right? And if you notice, if I hover over the switch statement right now, it still doesn't give me anything because I need these braces, right? These curly braces, right? So this switch is a control structure. That's what this is, just like an if statement, right? So it's not the same as an if statement. It does similar things. So let's talk about different ages. If I say case, I'm looking for a specific age, case 10, the person's 10 years old, right? Then underneath that I have to put this kind of notation, case, right? 10 for the actual number, right? And then some kind of break statement underneath, like this, break. Okay? That's the format you have to do for each case. The case, the value that you're checking. So I'm saying, is age 10? That's what I'm saying here. Okay, good. Now, in between the break and the case, you put your statements. Console.WriteLine. We'll say something like, so you're 10 years old, right? But that's specifically for 10. Right? What if the guy enters in 100 or 3? Will it go here? Case 10? What am I checking? If age is equal to 10, then do this. That's equivalent to what I just did. If I want to put a range, if I do, some languages allow you to do this. 10, and then, as an example, as a range, and we can put in whatever we want. You can't do that here. You can only put one value, right, inside the case statement. I can't do multiple values. What I can do is do another one. I can say case, as an example, if the guy is 15, right, case 15, console.WriteLine. You can almost drive, right? And we'll put a break in there. So that, again, it kind of gives some different cases. If it's 10 years old, if it's 15 years old, and if anything else, we can also put a default case. That's what it's called. So I can kind of go in here and go default, right? And between the break and the default, it'll capture everything else. So I say, well, if it's anything else other than 10 or 15, it's some other age. So we can just say, console.WriteLine, you are some other age, right? Actually, you know what? I can put in, if I really want to, for everything else, if it's other than 10 or 15, right? What can I put in here? If I want to do some interpolation, string interpolation, and put out the age, how would I write this differently, this line, on line 30? Here's my line 30. How would I write this differently if I want to put out his actual age that he typed in?
The curly bracket 0.
Okay, so I do that. So I go to do the stand-in, right? The placeholder, that's what it is, right? Then I go what? Comma, and then what? Right. And that basically what it says is take the actual age and put it in here. So you are, instead of some other age, we're going to get rid of this, and we'll say you are actually blank, right, years old. So that we know that anything else is going to get the exact age, but we have some special messages for 10 and 15. So this is what the if-else would look like. If age is equal to 10, then, right? So you're 10 years old, right? Else, if age is equal to 15, exactly equal to 15, then, right line, you can almost drive. Else, anything else, that's what else is. Default is like an else, a final else, right? You're actually blank years old and whatever the blank is. Okay, that's what equivalent to what the else, if else is, right? Now this is not a great example because there's not that many options. Sometimes what we do is we use switch statements. A really good use of switch statement is for like a menu. We'll do that next. So let's try that out. So I'm going to go like this and press start and run it, and let's see what I get. You enter your age. I'm going to enter 15, and I get, hey, you can almost drive. Right? Let me just change the way this looks just because we're together. I'm going to go to colors. I'm going to press white for the background, and for my screen colors, I'm going to go black. I'm also going to change my font to Consolas, and it's going to be 20. And press OK. Okay, there it is. So please enter your age. I've put 15. Hey, you can almost drive. Let's try that again. And I'm going to say something like this. So enter your age. I'm going to call it, 10. So we're going to get that, hey, so you're 10 years old. And then when we try the other one, just to test it out what it looks like, if I put in like 21, you're actually 21 years old, right, which is the default down here. So you see, it does these three cases just like I would normally do if, else, if, else, if, else, if, else. Sometimes it gets really painstaking if you're only checking one value. One thing that you can't check is multiple values. You can't do a range with the switch statement. You can't say, well, if case is 10 to 15, then do this. If case is 15 to 30, then do this. Can't do that. However, there are other workarounds. So this is the example we just kind of did. I'm going to just, let me go back there. And for those people who want to follow along on GitHub later on, I better just make sure that I kind of add that in. So changes, I'll say updated main. Okay. And I'll go into home, unsync commits, and sync, which will sync up everything with GitHub. Okay, good. Let's go back to this for a second, take a look. So again, sometimes you can see this, case 1, case 2, case 3, and 4, but there's no break, right? What this is called is fall through, right? So we have 1, 2, and then 3 and 4 give you this upper class. So you don't have to put a break for every case. The ones that you don't put a break for, like if I didn't have a break here, it would continue to fall through until it hits the break. So it would do all the code between the case and the break. So case 3 and case 4 would use this right line upper class. Okay, that's what it does. So here's a good example of an enumeration, right, with the switch. Remember we did in enums last time, right? Enums are like accounting, so the enum is a major, right, in this particular case. Remember what an enum is. It's like I want to create a grouping of like words, variables that mean something for us, almost like a constant that we're going to use. So I don't have to remember what they are. So for example, I want to say, if I'm switching major, right, I can say, when I say switching, I mean I'm using major to check. I'm checking major out right here. Major is an enum. So I start accounting at 1. I can say accounting, CIS, computer information systems, English, math, and marketing, right? So I say, well, I switch the major, and if case major.accounting, right, or case major.cis, or case major.marketing, all these things are the same because there's no break statements in between. They fall through, right? Then my message is major is in the business division. Break. Then I get out of that. When I hit the break, I leave the case the switch statement. That's how it works. Here's another, then I continue. If my major was English or math, well, the major is in the humanities division. Doesn't make any sense. But anyways, then I break out. Otherwise, the default means for everything else, that's what default is, then say department number is invalid. You put the wrong department number in. Somehow, the way it's switched through, there is no department like that. So really, that's how you can use an enum, right, an enumeration, right, with this switch statement. So that's very interesting because one, instead of putting numbers like you're in a department 1, 2, 3, 4, 5, right? What we want to do is some kind of descriptive name, which is accounting, CIS, English, math, and marketing, right? And we can do the same thing for, if we make a menu, right, a menu item, like instead of age, right, I can make it an enum, a menu that says I want to go, to choose option A, option B, option C, option D, whatever it's going to be, right? And depending on what I choose here, right, for example, let's do, I can kind of do something like this. Instead of please enter your age, let's change age, right, just for this example. I'll refactor this. So we're gonna change this up, and we're gonna say instead of age, we'll say favorite browser. We kind of did that before. Let's do it again. Favorite browser. Okay, so it changes to favorite browser. I'm gonna clickety clack. So favorite browser is what I'm looking at, right? Okay. And let's say, as an example, I want to, now it says, please, instead of enter your favorite browser, we can say, what's your favorite browser? What's your favorite browser? And let me just make sure that it looks correct. So it's not like chintzy favorite browser. The reason why you give me favorite is because the American spelling is what it's trying to find. I'm going to add to the dictionary so it doesn't give me that issue anymore. Okay, and this is my read line. I want to kind of get a choice for my favorite browser. Well, I can enter IE or Firefox or whatever, but I'm not looking for that. I'm looking for an integer that's related to my favorite browser, right? So what if I start typing some other stuff? I start to do one of these. So I say console.writeLine, and we'll do a write line here too for a second, right? Bear with me while I do this. So I'm going to create a little menu, right? So I'm going to say, let's do a little dividing line. What's your favorite browser? And in there, we're going to do this. Just follow me along. Type with me. Console.writeLine. And we'll say 1, Internet Explorer, right? Console.writeLine. 2, right? Chrome, right? Console.writeLine, almost like a little survey, right? 3, Firefox, and console.writeLine. 4, Safari. Right? So that's your questions. And then I want to do a console.readLine. It's going to say, what's your favorite browser, right? And it's going to wait. Now, I could do it like this, right? So I say question 1. Let's say question 1. Here we go. Question 1. What's your favorite browser? It almost looks like a little survey. 1, IE, 2, Chrome, 3, Firefox, 4, Safari. And what it's going to do is going to wait. After I go to Safari, it's going to go to the next line and wait. And then maybe I'll put in, just for the final thing, console.write. Please enter your choice. I'll say 1, 2, 4. Right? So basically what they're saying is enter whatever your choice is. Or please make your, or maybe please make your selection. Make your selection, which makes more sense. 1 to 4. Okay, so there's what it is, and then it's going to be converting it like we normally do. But now, favorite browser is the one I'm switching, not age. So I got to give some different options. So here's number 1. So I'm going to start out number 1. I asked for number 1, number 2, right? And we'll add some other ones, 3 and 4. I'm just going to copy these things for a second. Just bear with me while I do that. 3, 4. So 3 and 4. I'm going to change the value here. Right? It's more of a real world kind of example. Oops. 3 and 4. So we're going to say console.writeLine. If it's 1, i.e., you chose IE, right? And if it's 2, right, you chose the most popular browser. And number 3, if it's Firefox, that browser is pretty good, right? You chose IE. We'll make a what we call question mark there. So you chose IE, and the final number 4, right? We'll say you like Apple, comma A, right? And then the final one, the default case is, you know, something like invalid entry.
Or you don't use the internet.
No, because it's an invalid entry. Error.
Yeah, but
Invalid entry. There is no other browser because there's no other choices, right? So they can't enter 5. There is not a choice 5, right? So the choices are 1, 2, 3, or 4. That's what I'm asking them for, right? Please make your selection, and then we're going to print out this stuff, right? So if I was to do this, let me just enter another little console.writeline just to clean it up. Okay, and let's check and see how that looks, right? So we'll start it. Hey, this is what it looks like. Take a look. Hey, what's your favorite browser, right? Here's your question 1. 1 for IE, 2 for Chrome, 3 for Firefox, 4 for Safari. So I can put in a value. I'm going to enter a perfect value because we're not doing any validation right now. I'll say 2 for Chrome. Hey, you chose the most popular browser, right? If I ask it again, right, I can go 4. Safari. Hey, you like Apple A. And the thing is, what this is another, like I said, another conditional or decision structure as a recap to what this is that does, I look at this variable, favorite browser, right? And favorite browser can have only 4 values, case 1, case 2, case 3, or case 4, with a default value being incorrect because you can't have case 5 because my question only goes 1, 2, 3, or 4. There is no question 5, like other. Yeah.
you can technically change it to a string and then change it to IE, Chrome, Firefox, and Safari, the actual words.
Mm-hmm. But that won't help me.
But it would work in case.
It will, but that's a totally different thing. So now I'm switching the string value. I'm checking to see if my favorite browser, and in case I would put quotations instead of the number literal.
Okay.
Right. So here, instead of that, if I was going to do that way, instead of converting it, let's do your way. Right. Let's check that out. So what our friend here is saying is this. See, instead of prompt, and then I'm converting it to favorite browser. Let's just use let's just put our favorite browser 1, 2, 3, or 4 instead of that. Please make your selection. And we're waiting for Chrome or blah, 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 whatever they type in. But they have to type it in exactly, right? The disadvantage to that one is they might make a spelling mistake, right? Whereas I press 1, 2, 3, or 4, which is more accurate. A, B, C, or D would be the other option, right? As a single character. And that's why this makes more sense. Okay, so let's go back. So again, this is the switch statement. This is what we're looking at right now. So an alternate to the if else kind of loop that we do when we do some kind of we're trying to figure that out. This is something new. It's called the conditional operator, right? So this is another way you can check if and else. Take a look. Actually, it's called the ternary operator. Okay, it takes 3 parameters. So the syntax looks like this. Here's my test expression. I need to use the question mark. This is like a shorthand, right? Here's what happens when the result is true. Here's what happens when the result is false. And you might see this expression. You might see this in different places. It's called the ternary operator. Same way as we do if, else, if. But it's like saying this. If you only have 2 cases, if whatever they enter in is this, then true, else, false. That's how we do that all the time. If this, then true, and otherwise it's false. The ternary operator is the best way to put it in. If there's only 2 cases.
This is also like
Boolean. That's correct. The Boolean variable that we have here This is an expression we check. So example, the expression might be something like test score is greater than or equal to 60. That's the expression in this example. Put a question mark. If it's, is that true? If it is, pass. Else, with a colon, it fails. It's a very common expression syntax. You might see this not just here in C#, but also in Java, JavaScript, PHP, and so many other languages out there. They use the same kind of ternary expression, conditional operator. Okay, so let's take a look and see how that works. So when would I do that? Well, I entered Chrome, right? And I can make another check down here, and I can say, normally I would write it like this, right? If, as an example, I'm going to check just for Chrome now. So I'm going to say if favorite browser, right, is double equals to, 2, right? Because that's what I'm checking for, 2. Actually, I wouldn't do 2 in brackets, it would be 2, right? Because it's an integer, right? Then, here's my here's my what it would look like. I'm going to say, I'm going to set up another Boolean, another I'll say correct answer, right, is the actual variable we're going to use. We're going to make it a Boolean type, right? So my correct answer is either, or the answer is even true or false. Here, say answer. Let's just call it answer. Correct answer. Answer, right? If favorite browser is equal to 2, which is Chrome, right? Then answer, right, is equal to true. It's a true answer, right? Else, right, answer is equal to false, right? So there's all this line that's checking to see if your favorite browser is Chrome or not, right? There's 1, 2, 3, 4, 5, 6, 7, 8 lines, right? Check that condition, true or false. Well, you can actually write it like this with the ternary operator. Take a look. I'll wait till our friend does that. Ready? So this is 8 lines of code to check if it's true or false, right? Let's do it with 1 line. So we'll say this. We'll say favorite browser, right, is equal to 2. And we'll put this in brackets like this. Question mark. That is the then, right? True, right? We can say we want to return true, right? Otherwise, false. And we can say this with clarity that when I do this, if I look at the way it works, that's what I'm returning. So I want to say something like my answer is equal to favorite browser, true or false. It's 1 line instead of 8. I don't need to use my brackets. If I want to take these brackets away, like this is also correct. Sometimes I just feel there's a little bit more clarity when you surround something in parentheses, right? If I put parentheses around this, I know that this is what I'm checking. This is the condition that I'm checking. That favorite browser, the selection I made, is equal to 2, which is Chrome. Now, here's the thing where enums come in. We talked about enums briefly last week, right? Right now, I'm going 1, 2, 3, 4, right? 1, 2, 3, 4 means nothing to me. It's just numbers, 1, 2, 3, or 4, right? What if I created an enum, right, called browser? Let's try that. So I'll go at the top there, and I'll set up enum, and I'll call it browser. There's my browser enum. And inside there, inside my browser enum, I'm going to put in the types of browsers. So IE, right, is equal to 1. And then I'll say the next one is Chrome. And the next one is Firefox. And the next one is Safari. Right? Does that make sense to you? Those are all the different ones there. I believe I got to put that in there too. Let's make sure that's correct. So I don't want to make a mistake for you guys because that's just not right. I was right. Just no semicolon there. So let's take that semicolon away. So I say enum browser IE is 1, Chrome, Firefox, and Safari, just like it does here, right? And the reason why this is giving us an issue is because this enum is inside of my static void main, and I got to take this and put it outside of my static void main, just like we did last time, right? Because otherwise it doesn't know what the hell that is, right? Usually it's got to live in here, right? So now that it's over here, right, it understands that this enum is an enumeration. It kind of tells me that it's outside of my main method, that i.e., if I go browser.ie, that's equal to 1, which makes more sense, right? I can now, instead of doing case 1, case 2, case 3, I can actually check to see if what it is. So I don't have to look at 1, 2, 3, 4. I just have to go browser.ie, right? Which makes more sense, right? And then browser dot Chrome, right? And then let's see why it's giving me an error now. Tell me why it's giving me an error. Browser dot Firefox, right? And browser dot Safari.
It's
So
giving you an error because on the top part, it's still 1, 2, 3, 4.
yeah, who cares? I'm asking 1, 2, 3, 4, but what I'm entering is it's being converted to int32, right? Well, this is the problem, because these, if I look at what this is enum, right? If I hover over what this is, enum is not an int32, right?
So it's converted to enum?
Well, no, because an enum, what is it? If you look at what the enum is, if I hover over it, it says error, cannot implicitly convert type browser to int. An explicit conversion exists. Are you missing a cast? Right? I'm trying to convert something that's a number that's not an integer. It's not an integer. It's like a byte or a very small number, right? So when I pass information in to the console, right? I show you that thing again. And when I switch things through here, if you notice, the enum itself, right? When I read line from the console, here's how I'm converting. I'm converting to int32, right? Here's my int, here's my major, and if you notice, major lowercase m and major uppercase m, right? They're in the same class, right? This is just outside of main, like we said. But if you notice, we're not getting that issue, except for where I cast. Look how I'm casting. Here, see this line where I put these things in brackets? I got to do that. I got to cast major lowercase m with major uppercase m. I got to make sure that it conforms to the enum. This is where people are confused, right? But I'll tell you what it looks like. It looks like this. So it goes browser, right? Favorite browser. See, because my browser is this, right? Let's go back out here. Okay, and now let's see what it says for an error. It says, the type namespace name browser cannot be found. Please, are you missing a using directive or as an assembly reference? Which means either I spelled it wrong, right, which I have, or, you know, it doesn't exist. So there it is. So now browser glows green, right? And what I'm doing is I'm saying favorite browser. I'm casting it. Remember I talked about casting last week. It's actually another way of converting. We're casting browser, even though it's like integer numbers. Browser is an enum, so it needs to be cast into an enum. It's a different data type. It's not an int32. It's of type enum, right? It's a even though it's 1, 2, 3, 4, 5. It's not an integer 32. In fact, I think it's like a byte or something like that. It's a very small number, right? Or an int16, something like that. Okay, so now I can switch through and you can see that the names make more sense. Browser IE, browser Chrome, browser Firefox, and so on. And down here, instead of saying equals to 2, which means nothing, I can put in here browser, right, dot Chrome, right? So if favorite browser, browser.com, and of course I'm going to go do the same thing here where I cast browser, right? This is one line that does all the work that I would normally do with 8. It's called a ternary operator. Okay, a ternary operator. And what it looks like, if I go back here and kind of switch forward, it looks like this. This is the syntax. The test condition, a question mark, the true result, colon, and the false result. Okay? We see it all the time. For us, it's not going to be common practice, and I'm not going to test you on it. I'm not going to sit there and go, hey, put the ternary operator, make it one line. It's very efficient instead of doing if, else. And when you have two values, true or false, 1 or 2, up or down, on or off, one of those kind of things. It's a good choice to use if you only have two different values. Red or blue, white or black, one of those kind of things. If you do one of those things, then there's only two values, that's when you use ternary operator. Okay, the not operator is when we want to change the value of something to the opposite. Example would be, if I want to say that if it's false, not makes it false. If the expression is true and I put not in front of it, this exclamation mark, then it makes the expression, it turns it from false or true into false or false into true. It reverses the result. An example of this would be if not keep going. Keep going is equal to true, typically. We want to keep doing the game. All right, so let's say we have a game loop, and we say if keep going is equal to true, then do this game loop, right? But I can also put if keep going without equals to true, because if I just put if keep going, that's good enough, right, from testing. But I can also say if not keep going, so it's true result, I change it to false, then do this. So you might see the not operator very frequently being used. The other biggest errors, you'll see this error happen all the time. When you try and I kind of mentioned this last week in passing, when instead of using a double equal to compare, you only use a single equal. What does a single equal mean? It means it's an assignment. I'm assigning a value, and it's always going to be true. If I assign a value instead of my comparison in there, right, then it's always going to pass a test. I mean, it's going to be an endless loop. It's never going to break out of that loop. So it's always true if I assign something. And the good thing is that this won't cause an error. It won't stop you. It won't cause a weird error for us here in C#. But in other languages, it won't tell you that it's wrong because there's a lot of, like for example, in JavaScript, it'll just work. And you don't know what the hell's going on. Why is this not working? And it says, this is equal to this. Why? It isn't equal. But you've just made it equal because you use a single equal instead of a double equal. It's a syntax issue.
So here it helps you, but Java doesn't.
Here we have code hinting that tells us it's wrong. Okay, we talked about range checking last time, right? So here's where we kind of did this last time, where I kind of showed you that where range checking is messed up. So here's an example. If sale amount is greater than or equal to 1,000, well then this is true, 0.08. And now I'm going to check to see if sale amount is greater than or equal to 500. Well, that's true too, because the greater than sign makes this condition true as well, right? And if sale amount is less than or equal to $4.99, well, that's not true. If these two are true, this one can't be true. But these two are both true. And if you do this, why even bother checking this, right? Unless you want to do something else. You're trying to do something. This is a different way of doing things. I wouldn't recommend this at all. The better way to do it is do this, right? If sale amount is greater than or equal to 1,000, right? So it's higher than 1,000, then do this. If it's greater than or equal to 500, right, then do this. Else if. One or the other. Here, it's one and the other. You check every if statement. Here, you check this one, and if this one is true, you skip these two. Right? That's what the else if does. Right? Here, you only check the second one if the first one fails. Just like we did the case statement. If the first case fails, you check the next case and the next case. And if you notice how this is written, we should really put curly braces here too, because this is really bad form. Right? Okay. And then, of course, we talked about and or, where you can combine. You can do compound statements. Right? Double ampersand, it says this one and this one. Do you guys ever study logic and math at all? Oh. Let's do a little bit of math. so you guys can understand what I'm talking about. I'm going to pull up fireworks just for demonstration purposes here, right? So we can draw together, right? Okay, so I'm going to pull up a new canvas with fireworks. I'll make it like 500 by 500. And I'll put a white background. Okay, so here's 500 by 500. And you know what? I'm going to draw some stuff here so you can get kind of the thick of things. So here's a set. Okay, so the set of all numbers, this is the set of all numbers, or the set of all conditions where, just make sure we draw something. How about that? How about them apples? And let's make sure that it's a little bit thicker. 6, there we go. So in this circle, you see the circle? This represents, right, the set of all boys. Set of all boys. Okay, so all boys. I want you to tell me, when we do a little bit of math here, what do I mean when I say all boys? What's the set of all boys mean? First of all, what's a set? A group of things, whatever they are, right? So when I say the set of all boys, right, what am I saying? What are the words you look at? Set of what? All boys. All. What does all mean? Everything. That means every single boy that ever exists. That's what it means. Boys. Set of all boys. That means boys that have dark hair, boys that are tall, boys that are short, boys that are every kind of boy. Okay, let's do another one. If I do another set, and this is where people get funky around this stuff. Here's a set of all girls, right? You see the set of all girls. They're two different sets, right? Because they're two different groups of people that are not the same. It's either the set of all boys or the set of all girls, but there is no girl boy in the middle, typically. I'm just saying, right? So, however, we can also make another circle, right? Where we can, and this is where people get confused. Here's the next circle. So we'll pull this one down for a second. Set of all boys, set of all girls, and this one here, we'll call it people wearing blue. Now that could be either boy or girl, right? It could be the set of all people, anybody. That can be anybody wearing blue. Okay, I'm going to make that a little smaller so you can see what that is, so you're not confused even more than where I'm going with this, because you're like, where is he going with this? People wearing blue and boys or girls, right? Well, the thing is, this is what logic is all about. If I take this and combine it with this, and I overlap it, let's say the circle now, I kind of take away the, the background. Let's take away this background too. Same thing with this one. Now, la la la. Sorry. I meant this one, and this one, and this one. What I meant to do is do one of these and carry this over. So we have people wearing blue crossing over with the set of all boys, right? So here on this part of the circle, not including this part over here, is the set of all boys. This is people wearing blue. And in the middle, where both things cross over, are boys that wear blue. The set of all boys, people wearing blue. So boys wearing blue. It's a much smaller group. This is a bigger group, this is a big group, and this is a nice small group. The more I cross over, the more boys are wearing blue, right? So I can do one of these. I can say if it's a boy and they're wearing blue, then this is true. This is the true piece, right? If I say or, that's what and is. And means both this one and this one have to be true, which means the solution is in here, in the middle. That's what and means. Both conditions have to be true, which is a much smaller set of conditions, a much smaller range. If I say or, set of all boys or people wearing blue, that means all of these people plus all of these people. This could be girls and boys, right? Mix of girls and boys, right? But it means both these circles, this group of thing are true. It's either one or the other that's true, which means all of that is true, right? All that is okay to be true. I can also cross the circles over like this. So I can do one of these, right? So I take this and cross them over like this. So I can say this: the set of all boys and people wearing blue, or the set of all girls and people wearing blue, which means these little areas here, this area here and this area here, but not this area. Not just people wearing blue, and not just the set of all boys, and not just the set of all girls. It has to be both this set and this set. It's a union is what it's called. Okay? So we do this because when we talk logic, I use compound operators, the double ampersand for and the pipe, double pipe is what it's called for or, to combine two conditions together. If first condition and the other condition means both conditions must be true in order for the whole thing to be true. If the first condition or double pipe, the second condition, either one of those conditions can be true for both conditions, for the whole condition to be true, one or the other. Okay? So this is a very, very basic example. And back in when I studied logic like 25 years ago, we had this kind of simple example that we were using, but they still hold true today. So whenever you look at ranges like that or conditions, always think about it. What set, what grouping am I checking? Because sometimes what happens is when you do your logic, you can kind of pare it down and say, but this is the same thing that I'm saying. If I say greater than or equal to, I have an or in there, or equal to. That's two things here. I'm going to change this from a set of all boys to greater than. Let's just change this whole thing to greater than. Right? So here's greater than, and this is equal to. Right? Greater than or equal to, not plus. Right? So here's equal to. I'm going to put this over here in the middle. And this is greater than. So this is all the things that are greater plus all the things that are equal. Right? And I'll make this, let's say, the same thing. So the greater than, if it's greater than, it's true. Or means this circle plus this circle together. Right? Either one or the other. Right? Greater than or equal to, including this piece. Right? And that's why it's tricky when you say greater than or equal to. If I just say greater than, I'm really saying this, greater than. Doesn't include equal to. That's a totally different set of people, right? And equal is not just equal. When we do equal, we do double equal, right? We can do a comparison. So if I say either this one, either greater than or equal to, but not both, you can have that too. So it's greater than or, right? And so I'm saying or it's equal to, but not both. How can I write that down? If whatever the thing is greater than, right? Only greater than. And there's another thing called, it's an exclusive or. Either one or the other is true, but not both. It's called exclusive or. Right? And we have a way of checking that here too. We don't normally do that, very rare. We check one or the other, but not both. Okay? And we can also say the other one, which is not. Not is the apostrophe. That's the sign for the apostrophe, or the exclamation mark, I mean. So exclamation mark is not. So if I say not, if I go like this, take not and combine it with equals, right? I get not equal, right? If I say this, not greater than, right? And if I combine it together with this one, it's kind of weird, but I could do something like this. Not greater than or equal to. Here, put it together. Which is this little piece here. That's not greater than or equal to. Right? So I'm saying you can combine these sets to kind of zero in on the range when you do condition checking. And that's why you should check it out. Think to yourself, is the first condition, does it clash with the second condition? Because if it does, why do I need the first condition in the first place? You only want to test or check a condition one time. You don't want to make sure that it's overridden by some other condition that you're checking. So if you do a series of conditions, one after the other, and one supersedes the other one, take one out because you don't need it. Like if one range runs into the other range, it makes no sense. You shouldn't use that.
You're saying like the more conditions you have, the more accuracy you have?
You can, but also it gets very tedious, right? You can be very, very specific, but then you're going to make if, else if, else if, else if, else if, else if, else if. You kill yourself with else if, yes.
So, for example, if it's 500 people, you want to, if there's 500 people and you want to see if there is more than 300 or 300.
That's a different thing. So that means you're saying 500 people greater than 500? What are you checking?
Yeah, greater than 5. If there's 500 people and you want to
Equals to 500.
Yeah.
So okay, here, this is what you're doing. So you're saying equals to 500. Oh, if I can actually type properly in here. So equals to 500. That's the condition, right? So you're checking to see if this group is equal to 500. Whatever you're checking, the value, the number of people is equal to 500, whatever. And what are you checking here?
And I'm checking there if it's like more than 450. That would also include 500.
Correct.
So that's what I'm saying.
So if you do this set of greater than 450, it overlaps with equals to 500, right? Because this condition is true for 500 and things above 500, right? So there's an overlap.
Take out the 500?
You don't need the 500 anymore because unless specifically you want to do something different with 500 than you want to do with other numbers. Like if you say if it's greater than 450, then do this. And if you check again, if it's equal to 500, then also do this, right? Because both conditions are true. It's greater than 450 and it's equal to 500, right? Both conditions are true.
Isn't that sign, isn't it the other sign?
Greater than or equal, if it's this, right? Then you're checking to see if it's 450, greater than 450. It's true, greater than 450. And you're checking to see if it's equal to 500.
Yeah.
For the second condition, that means only this one fires for the second one. Yeah.
Without the equal to, you're not including the 450.
If you just pull this back, if you don't say greater than, if you say let's say greater than 450,
Yeah.
right? And then let's keep typing. Greater than 450, and you go and there's the double ampersand, and less than, right? Less than 500, right? They won't intersect. That won't happen. So it's greater than 450 and less than 500. It's a specific range that will never touch. Like it won't be together, right? Here's a set of all things greater than 450 and less than 500 because you have these double ampersand. Both conditions have to be true for this whole condition to be true.
So that's 451 and 499?
Correct. Greater than 450, 451, that's greater than 450. These are whole numbers too, right? I can also check doubles or floats. So greater than 450 could be 450.000001 if it was a double, right? In this case, because we're checking integers, it'd be greater than 450 is 451. And then here, this is less than 500. If it's an integer, it's 499, like you said. And this is only 500. And I can make another one, right? If I want to check greater than 500, there's another one that doesn't collide. This one doesn't collide with the other one, right here.
Man, that's one specific number.
Yeah, no, let's put this in there again. So we'll say this one here will be, this grouping is greater than 500. Right? So anything greater than 500 is this. It's a big circle. This one would be a much bigger circle because if I was going to do this one, and just for proportional reasons, anything greater than 500 is 500 all the way to infinity. So it's like, that's greater than 500, right? All the numbers greater than 500, which is every single number.
So then that number
It's like the set of all boys greater than 500, right? And this one is equal to 500, so this one's going to be really tiny, right? If I want to look at scope, right? This is what it really should look like really tiny. Let's make it like, so it's really small. So we can just fit the thing in, the text in there. There we go. Okay. And then this is obviously a much bigger number. That's how it usually is. So it goes like this. And they touch, right? Because they're just at the edge. They're not equal to ever, but they pass through each other. They're not intersecting. They're touching. They're adjacent conditions. They're conditions that are one next to, and that's how you want to do conditions. You want to do so that there's no gaps between the conditions. Because if I don't check, like I haven't checked anything less than 450. If I say less than or equal to 450, that's including 450. If I say less than or equal to, right? That's another one I can check. So let's check that one out. And that's what
So
the thing is
so the
with conditions. This is where I want to tell you this stuff. With conditions, you have to be very careful, very, very careful, how you phrase them, because the computer's not going to help you. It's not going to sit there and go, oh, this is bad because what you're doing is, you're going to include a bunch of numbers you don't want to, or there's an overlap. It's not going to tell you that.
So wait, so the number that's the gap that's there right now is
Less than
is 450.
less than 450 itself, the number 450, and anything less than 450. That's the gap. So if I want to do this again, I'm going to copy and paste, and this would be the one way we could write it is less than or equal to 450. Now that includes everything.
If you were to make it just less than 450, then 450 would be the only gap.
That's correct. There would be a gap between 450 and 450. Less than 450 would be 450. The only number that would be left out. So you can never get 450. Never check for that. And this would be a big number too, because see this? I'm drawing it small, but it's really not that small. Why is it not small like this? Why should it be bigger than this, or just as big as this?
Because there's less numbers.
No, there's just as many numbers.
It includes negative.
Correct.
Oh, it includes negative?
Of course.
Oh, okay.
So this can go as high as you want. This would be like just as big as the other one, right? This case here, because it includes all the numbers that are less than 450, including all the negative numbers to infinity, to negative infinity. So be careful when you have these open-ended things. So this is what they're called. This is a closed-ended condition, right? Greater than 450 and less than 500. It's closed, right? This is certainly closed. It's only equal to 500. Only one option here. This is an open-ended condition that goes to infinity, 500 and up. This is 450 and down, right? Or greater than 500. This is 501 and up, actually. And this is 450 and down. So be careful when you phrase these things. It includes all the numbers that are greater than 500 and all the numbers, including negative infinity, like to have forever until like the stars burn out. Less than 450.
Wait, so there's technically more numbers in the 450 than 500?
Technically not.
Why?
Well, technically because they're so close together, 500 and 450. Yes, you're talking about the difference of 50 numbers. But the number, when you compare it to the size of infinity, is so small, right? They're all technically almost identical.
But
right?
450 is
50 numbers different.
450 positive.
Yes.
So I have to consider that.
Yes, there are. Whereas obviously there's going to be 450 positives. If it was exactly zero, so if you say greater than zero or less than zero is one of the two things.
Then
Like,
it'd be
exactly. So obviously 450 is a bigger number, but it's only 450 numbers bigger, which in the space of infinity is like a little dot, right? So for mathematics, it's a very small difference. Okay, are we clear on conditions? Because you're going to see these conditions come up over and over again. And I'm going to go, aha, this condition and this condition are identical. What are you doing? Why are you checking it again? Because it's the same. You're checking the same thing twice. Or they're overlapping, like I said to you. You checked greater than 450 and greater than 500. Both conditions are true. Right? If I did this, if I said greater than 450 and greater than 500, well, it's not like this anymore. Now it looks like this, right? It looks like this. They overlap. Let's say greater than 450 is like this, right? A little bit smaller, but the number, this circle is just overlaps. It contains 500 too. It's way big. And it also contains 500. It also contains this as well. It's all this whole thing. If I say greater than 450, the whole screen is contained with that. Because it includes this one, this condition, and this condition. It's all greater than 450. Right? That's why you can't do a condition like that. This one, if I was going to resize it, right, it'd be off the charts. You couldn't see it at all. It'd be just like one of these. It's everything, right? Because it's true for it all. It's true for all four conditions. That's why you have to be careful, because that's one condition that covers them all. So why bother with the other ones?
There's so many others.
Right? So just to think of that, I know it's philosophical, but one of the ways that we do a lot of it's called deductive geometry or deduction, right, is to remove all the conditions that are possibly true, and whatever's left is the answer. Deductive. Okay. So let's take a look. So again, this is the pipe, right? The double pipe is either this one or this one. Okay, so what is it saying? If pay rate is less than 5.65 or pay rate is greater than 60, something's wrong. Either one, either condition, it's wrong. That's a big, less than 565 to infinity, that's what less than means, and greater than 60 to infinity, a lot of numbers there, it's wrong, because they're saying you can't get paid less than 565, and you can't get paid more than 60 bucks an hour in this particular case. Here's the problem. Make sure that if the sales code is not A or B, the customer gets a 10% discount. Well, here's the solutions. If sales code is not equal to A and sales code is not equal to B, both conditions have to be true, then you get the discount of 10%, right? Not equal and not equal to B. Or this is the other one. If, and see how there's brackets like this, the whole thing is not true, then the discount is 10%.
So there's a different way of doing the same thing.
It's the same thing. All I'm doing is reversing the positive into a negative. So this condition is true. If sales code is equal to A, all right, or sales code is equal to B, that means that condition is false, right? And I want to say if not these things are true, if it's not false, if it's not true, it's false, then we're good. We're good. It's the same thing. That's why be careful with the nots. This is it invalidates. It changes around the condition from true to false or false to true. It kind of toggles. It's called a toggle. Toggles it on or off. That's all I'm going to cover for now for this piece. The rest is about GUI programming, and so it's a good place to stop and take a break. Have a bit of a bathroom break or something. Take 10 minutes and come back.